Okay, today's lesson is called Laws of Indices. Just to have a little reminder of what you did in your last lesson, you were looking at power notation and what do things like this mean. So 3 to the 3, for example, that means 3 times itself 3 times. Or 3 to the power of 5, that means 3 times 3 times 3 times 3 times 3. And it's just a shorter and neater way to write the same number so that we don't have to write out these long expressions. We can just write 3 to the power of 5. So today we're going to be looking at what happens when we multiply and divide numbers like this, so numbers that have powers. So firstly, let's look at multiplying. So what happens, for example, if we did 3 squared times by 3 cubed? Well, let's write this out. So we've got 3 squared, we know that means 3 times 3, and we've got 3 cubed, and we know that that means 3 times 3 times 3. So altogether there, we have 5 3's, 3 times 3 times 3 times 3 times 3, so we can write this as 3 to the power of 5. How about when we have an algebraic expression instead of a number? So we might have something that looks like t to the power of 4 times by t to the power of 3. Same as before, we're going to write this out as t times t times t times t, that's t to the 4, times by t times t times t, that's t to the 3. Altogether there we have 7 t's, 1, 2, 3, 4, 5, 6, 7, t to the 7. In both of these examples, if we look, we've got the two powers here, 2 and 3, and we add them together, we get 5. And here we've got the two powers, 4 and 3, we add them together and we get 7. And this is true always when we have this same number here, this same base. So here we've got t's and here we've got 3's. So provided that the base is the same, when we multiply them, we just add the powers. So this is our first rule, our first indices law. So for any numbers y, a and b, so y is going to be the base here, we just add the powers together when we multiply them. So an example, 3 to the 5 times by 3 to the 6, we don't have to write out all of these 3's, we just add them together. It's a nice little shortcut. So 3 to the 5 times by 3 to the 6, that's going to be 3 to the 5 plus 6, which is 11. So there's a couple of questions here just to have a go at. I just encourage you to pause the video here and give it a go. Have a think about what it might mean, applying the rule that we've seen. Okay, hopefully you've had a little go at that. So I'm just going to go through the answers. So we're applying this rule. So the first one, we've got 2 to 3 times by 2 to the 6. So we've got 2 to the 9. The next one, we've got a to the minus 4 times a to the 6. Now, it's absolutely fine to have a negative power. Now, you might not have seen something that looks like this before, but it's absolutely fine. And next lesson, we're going to talk about what a negative power means. But for now, you just need to apply that rule again. So a to the minus 4 times by a to the 6 is going to be a to the minus 4 plus 6. Minus 4 plus 6 is going to give us 2, a squared. Okay, and the last question we had, simplify 3x cubed times by 2x to the 6. This looks a bit weird this time because we've got a mixture of numbers and algebra in there. What we're going to do is we're going to times the normal numbers together first, and then we're going to deal with the x's. So first of all, we've got 3 times 2. 3 times 2 is 6. And now we're going to look at those powers. So we've got x cubed times by x to the 6. That's going to be x to the 3 plus 6, or x to the 9. So we're just going to multiply the numbers first, and then we're going to deal with the powers. Okay, so that's multiplying. Let's have a look at dividing. So when we divide numbers with powers, what happens now? I'm going to write these out. I'm going to have a fraction because division is exactly the same as a fraction. So on the top, I'm going to write out 6 3's. 3 to the 6 is 3 times 3, 6 times. Divided by 3 cubed, that's going to be 3 3's. So we've got this fraction now. And I'm just going to simplify it a little bit. Any number divided by itself is 1. So I can do 3 divided by 3 is 1. 3 divided by 3 is 1. 3 divided by 3 is 1. So those 3's all cancel each other out. And what we're left with is just this 3 times 3 times 3 on the top of the fraction and a 1 on the bottom. So it's 3 times 3 times 3. And now we can write this nicely. We can write this like 3 cubed, or 3 to the power of 3. So you look at these numbers again, we've got 6 here and we've got a 3 here, and it comes out as a 3. But we've just done 6, take away 3, and that's given us that 3. And this is true for any numbers again that have the same base. So we've got rule number 2, y to the a divided by y to the b is equal to y to the a minus b. And here's a quick example down at the bottom here, 3 to the 8 divided by 3 to the 6. Put it into the rule, 3 to the 8 take away 6 is 3 squared. So again, we don't need to write out these big fractions and cancel them all out and check that it works. We can just apply this rule. So I would like to have another go at practicing these. So I want you to look at these questions, pause the video here, and give it a little go yourself, applying that law. Okay, hopefully you guys had a chance to practice those questions. I'm just going to go through the answers now. So t to the 7 divided by t to the 4. We're going to use the rule. We've got the same base there, so t to the 7 take away 4 is going to be 3. 6 to the 3 divided by 6 to the 7. We're going to come out with a negative power, but that's absolutely fine, like we said earlier. So 3 take away 7 is going to give us minus 4. 5 to the 6 divided by 3 to the 7. Now, I wonder if any of you tried to use this rule and came out with something like 5 to the minus 1 or 3 to the minus 1. You can't do this. These have not got the same base. So this was a trick question, a little sneaky question in here to see if you'd notice. But these have a different base, so you can't apply this rule here. So when it says simplify 5 to the 6 divided by 3 to the 7, you can't simplify it any further, so you can just write it again, 5 to the 6 divided by 3 to the 7. And the last one, like with multiplying, we're just going to do the division with the normal numbers, and then we're going to deal with these algebraic expressions. So firstly, we're going to look at 12 and 2, so 12 divided by 2, that's 6. And then we've got w to the 4 divided by w squared. That's going to be w to the 4 take away 2, w squared. Lovely. So that's division. So that's our second law. The final thing I want you to look at in this lesson is the 0 power. So what does it mean to be to the power of 0? So what does 4 to the 0 mean, is my question here. Because we have a very good understanding now of what it means for 4 to the power of 5, say, 4 to the power of 5. We know what that means. It's just 4 times itself 5 times. But what's 4 to the 0? 4 times itself 0 times? Let's see if we can try and make it using the laws that we've already learned to see if we can try and work out what 4 to the 0 means. So say let's just start with 4 squared. I want to divide it by 4 to the power of something so that I get 4 to the 0. So using my division law, I'm going to do 2 take away something is equal to 0. So if I just put another squared there, 4 squared divided by 4 squared, that would be 4 to the power of 0. So I've made it. I just need to work out what that actually means. So 4 squared, I know that. I know my squared numbers. 4 squared is going to be 16. So I can put that in. 4 squared divided by 4 squared is the same as writing 16 divided by 16. And 16 divided by 16, well, that's actually quite simple. Any number divided by itself is going to be 1. So 16 divided by 16 is 1. I've worked out 4 to the power of 0 is equal to 1. Okay, so that's what that means for 4. But what does it mean, say, if I now look at 10 to the power of 0? What does 10 to the power of 0 equal? I'm just going to argue it in exactly the same way as we did with 4. So let's look at 10 squared. And I'm going to divide it by 10 squared. And that will give me 10 to the 0. 10 to the 2, take away 2, it's going to be 0. 10 squared is 100. 100 divided by 100, same as the I root of 16 divided by 16. Anything divided by itself is 1. So 10 to the 0 is 1. So is this true for every number? Yeah, because any number, I could argue that same argument that we've done for the 4 and for 10. So for any number, A, if I put it to the power of 0, it's going to equal 1. So that means, say, let's take 55 to the power of 0, that's 1. If I do 782 to the power of 0, that's 1. If I do 0.0037 to the power of 0, that's 1. If I do 3.1415 or pi to the power of 0, that's 1. Any number. So we've got 3 rules that we've looked at today. We've looked at the multiplying rule, the dividing rule, and the power of 0. Give the questions a go on the attached worksheet and then upload your work and show it to your teacher.